So good afternoon, everyone. It's 12 o'clock noon, and I'm here today with my good friend Andy Try, and we're going to talk about No Country for Old Bears. Um, I heard this presentation a while back. He did an excellent job, and I called him up immediately and said, you got to do a show on this one. So he agreed. So Andy, I'm going to turn the camera and stuff over to you. Tell the folks a little bit about yourself and start your presentation.
Sounds good. Thanks for the intro, Craig. Hey all, I'm Andy Try. I'm the Bear Project leader. We're charged with providing information to make management decisions about how to keep a healthy and resilient bear population statewide. And so I'm going to talk a little bit about some of the stuff we've been working on. This is the 40th year of the Bear Project in its current form. This year, this is the 40th den season for my predecessor, Dave Garcelis. But I stand on the shoulders of giants here. This is a lot of data that was collected over the years, not just by me. I'm just presenting it as part of the group. I'm going to kill my video here and we'll get rolling. All right, so make sure this works here. Beautiful. All right, so whenever you're managing a population of animals, you need to understand the components of what's called the BIDE model, B-I-D-E. And it's just a handy mnemonic device to think about all of the important factors in what influences a population of animals or any living thing, to be honest. It's births, immigration, so things moving into the population, deaths, and emigration, things leaving the population permanently. And so understanding the cause and magnitude of mortality is really important for management here at DNR. We need to know what's causing mortality, how to change things, and what we can control, what we can't, and what we can mitigate if mortality seems exceedingly high and we want to increase the population of animals. For most mammals, direct mortality of females is the most influential factor when managing population. That holds true for a lot of bird species as well. Females are kind of what drives the boat. With bears, parental care is provided only by the females, and so that's what drives the boat for us, and that's mostly what we work on. But males are important as well, at least for one component. Early on, there was a foundational paper in 1981 that claimed that bears are the slowest reproducing mammal in North America. And so this is, at the time, seemed sort of true. Bears take a long time to reach that age of first reproduction. But for the most part, the paper is bunk. It does have some value for management, but the claim that bears are the slowest reproducing mammal is not really true. Once they get going, they can really increase fast. So they introduced this idea of maximum sustained yield for bears. It's still used widely, and what we mean by yield is the number of animals in the population that can be removed in any given year. Often this is done with regulated sport hunting. But there are other ways you can do this. It's a term that was pulled over from fisheries. Wildlife often lags behind fisheries in a lot of ways, and so we tend to beg, borrow, and steal things from fisheries in general. So thanks, fisheries, for maximum sustained yield. Generally, for the eastern United States, less than a 20% mortality rate is kind of a common goal for population growth of black bears. In the western United States, those bears reproduce more slowly and have smaller litter sizes, and so they can't quite sustain such a high mortality rate. But given the statewide long-term data we've collected over the last 4 decades, you're dealing with roughly 2.5 cubs, 2.6 cubs per litter, and a 2-year interbirth interval. So the females will give birth to cubs in January. The cubs will stay with mom all the way through the first year, and then into May or June, the second year, about 17 months or so. And then mom will kick them out, breed again, and then she'll have cubs the following January. So it's a 2-year interbirth interval. And that gives you about 1.3 for a natality rate for this graphic. And so based on those old maximum sustainable mortality rates from Bunnell and Tate, we're looking at about a 20% mortality rate is what their paper suggests we can maintain. Historically, statewide bear population really varied widely. We started off somewhere between 7 to 10,000 bears back in the early 80s, shot up to somewhere between 20 and, depending on which method you use, 25,000 bears. This line just shows kind of the middle average based on some harvest reconstruction data. And now we're sitting somewhere between 13 to 17,000 statewide. So we drastically increased and peaked out about the late 90s, early 2000s, and then declined by half again by the mid 2010s. 2013 was kind of rock bottom, and then we've been increasing ever since. At a statewide level, the bear population's in a good spot. It's stable to increasing in most places. There's a few little trouble spots that are still declining, but those seem to have stabilized over the last couple of years as well. There are other ways you can estimate harvest rates, other methods, and so we use the Fraser method just as a really coarse index of harvest rate. And you can see when we hit above that 20% estimated harvest rate, that's when the population starts to take a turn. So that middle bar, it's about 24% harvest rate. That was right in the late 90s when the population started to take that turn. And then as the population declined and we've pulled back harvest, the estimated harvest rate has dropped. So Bunnell and Tate, that 20% rule is probably fine, but it's pretty coarse. And so to increase that, increase our precision and provide better data for management, which is our charge here in the Bear Project, we decided to look into this a little further. Generally, we use this information in an adaptive management framework. What that means is that we'll set a quota out for the total number of hunters that can go out and pursue bears based on the harvest information that comes in that year. We can adjust the quotas up, down, or keep them stable. We also use other information from collared bears, natural bear food indices, human bear conflict levels, that sort of thing to inform our management and our management decisions and quota decisions. But this is kind of a more long-term look at the data that we've synthesized. And so, for the state, we manage populations through hunting. That's our primary tool that we can control. And so we want to see how effective that might be. So the research questions based on that would be, what's the primary source of mortality for bears in Minnesota? How does that vary across the state? And then digging into the largest source of mortality, how does that vary with the demographics of the bears, hunter quotas, food conditions, that sort of thing? And so we'll get into it. So looking at the overall study areas, I should say, over the last 4 decades, we've been in the Chippewa National Forest the longest. We've been there since the early 80s. It's large chunks of public land. It's the most heavily eroded national forest in the country. It also has the highest density of lakes of any national forest in the country as well. So bears in that area probably would have higher vulnerability to hunting. That likely would be a mortality source that would drive that. Camp Ripley Training Center, we went there, started there in the early 90s, and we've had bears there ever since. There's no hunting at Camp Ripley, but Camp Ripley is bounded by 2 highways, 371 and Highway 10. And so it seems reasonable that vehicle collisions might be a big source of mortality there. Voyageurs National Park, way up in the northern part of the state, we were there from the late 90s to 2020. That has no roads within the park and is essentially a peninsula out surrounded by 3 lakes. And there's no hunting within there as well, as there is in most national parks. There's very little. I can't think of one where there's bear hunting allowed. And so there's no roads and there's no hunting. So probably natural mortality is going to be the biggest mortality source there. Northwestern Minnesota, this is mostly Marshall County, but there's some work up in Kitson and but primarily Marshall County is where we were looking. 2007 was when we started up there. And we ended that study in 2020. Hunting and agriculture are likely going to be the driving forces up there. There's large chunks of public land, lots of really nice WMAs up in that area. In addition, it's a huge area of production for sunflowers and canola, but primarily sunflowers in that area, as well as some corn that's popping up with shorter rotation. So agriculture is a big deal, and we have these patches of little chunks of lowland forest, some oak ridges, but lots of stretches of agriculture in between. In addition, with this study, we started using big ear tags as well to help the hunters identify these bears, so that might play a role in what we're looking at. We looked at the proportion of mortality due to all these different sources listed above. Natural mortality, these could be injuries, these could be bears killing other bears, these could be wolves killing bears, this could be disease, although we find there's not a lot of disease in bears in general. Vehicle collisions in the lower left, legal hunting in the bottom center, other human-caused mortality, generally this is poaching, and then in the upper right, human-bear conflict, where bears are shot as a nuisance. Our hypotheses for this cause-specific mortality part of the study is that it would differ by each study area. We figured in the Chippewa National Forest, hunting would be the largest mortality source. Camp Ripley, vehicle mortality, because there's no hunting on camp. In northwestern Minnesota, human-bear conflict, bears being shot as a nuisance would likely be the driving source of mortality there. And then Epid voyagers, natural mortality, because there's no hunting in the park and there's no highways nearby. And so that agricultural matrix I was talking about in the Northwest, that kind of is what it looks like from the air in that lower left-hand picture. Chippewa National Forest is on the upper left. That Brainerd Country, Camp Ripley Training Center, that's in the upper right. You know, it's more open landscape with a fair bit of oaks, and then Voyagers is in the lower right. So this is kind of a big surprise to a lot of folks, but in every case, bears are shot by a hunter as the leading cause of mortality. Hunting is the largest source of mortality for any of our collared bears across the state, no matter where they are. Even in those unhunted zones. In Camp Ripley, the next largest source of mortality is vehicle collisions. In Voyagers, the next largest source of mortality after hunting is natural mortality. And then for the Northwest, where it's a hunted population, but there's large ear tags and large amount of agriculture, it's split between shot as a nuisance and vehicle collisions for 11% respectively. So, you know, we're dealing with around 400 or so mortalities. In general, we're talking about relatively small sample sizes for any sort of bear study or wildlife study in general, but so Camp Ripley, Voyagers, and the Northwest, but still these are sufficient sample size to at least look at proportions. A note on cub survival, we don't really know what kills cubs. We don't really need to know what kills cubs. Cubs are not legal to be harvested in the state of Minnesota, but cub survival is really high. Moms are good, bear moms are great parents and look out for their little ones. And you know, cub survival is pretty high. That's much higher than average fawn survival with deer or a lot of other mammal species as well, partially due to that intense parental involvement and care that's provided. So how is hunting the largest source of mortality for some of these places where you can't hunt? It's kind of a weird paradox. This is a graphic or a video showing the movements of a bear that was collared at Voyagers National Park in the summer of 21. And this shows why these bears are vulnerable. So we're going through spring. They're kind of on the edge of the park right now. We've made it to May. Now we're on the mainland and in the edge of the park. And then all of a sudden in midsummer, the bear goes all the way down to Grand Rapids on the edge of town, and then through hunting season sticks down in that area and then by mid to late September is already back in Voyageurs National Park. So bears migrate. They'll migrate hundreds of miles sometimes. In general, the females don't migrate quite as far as the males do. Females will often go between 30 to 60 miles. Males will often go up to, I think the longest I've seen is 150 miles. In general, this graphic on the left shows from the Chippewa National Forest study area, just to locate you. So in general, the bears from Grand Rapids seem to head south and to the south and west during migration time. There are kind of traditional travel routes and feeding grounds. There's some down at Mud Goose Wildlife Management Area, just west of Grand Rapids. Moose Lake, there's some good oak stands. This is up near Deer and Moose Lakes in the Chippewa National Forest. And then down by Reamer, Outing, that kind of country, there's some other traditional feeding areas as well. But in general, the bears are heading to this part of the state that's really critical. It's got a lot of oak in that area of the state, and it's quite a good place to fatten up before winter. As I mentioned, it's not always north to south migrations. Here's some south to north migrations. These are two bears that were collared in the Pillsbury State Forest. And they stay in the Pillsbury until about mid-September. And then one of them goes all the way to the dam at Lake Winnibigoshish. The other one goes to the south end of Leech Lake. Now, the one in the red went all the way back to the Pillsbury State Forest before den up. The one in blue decided to den up near Willow Lake, near Reamer, and then came back in the spring. But it's this area, kind of west of 169, east of 371, and south of Highway 2, is really critical for bears in the fall. It's just packed with oak acorns, oak forest, I should say, and they really munch those acorns. This is some footage from a bear that had a camera collar on it. And as you can see, she's munching acorns off the ground, just going to town with acorns. This bear really never stops when she's eating, but essentially for a couple weeks, maybe 3 to 4 weeks in the fall, she just eats acorns all the time. That's basically the only footage, is when she's sleeping or eating acorns. This also drives reproduction across the state. As I mentioned, bears are kind of slow to reach reproduction. And so age of first reproduction for bears on a statewide average is 5. What that means is from the time when a cub is born to when it has its first litter on average takes 5 full years. That's longer than any of the other mammals that we have in the state of Minnesota. And it also explains why it takes more time to increase a bear population after a couple years of high harvest. In general, it's food conditions and local habitat conditions that drive when bears reproduce. So down in the southern part of Bear Range, so those are those 4 permit areas down in kind of the darkest of green colors. On average, bears there reproduce between 4.5 and 5. Then there's a band of kind of average conditions, and so the bears there reproduce between 5 and 5.5. That's kind of what we would consider traditional bear range. That Grand Rapids study area is right in the middle there. And then as you get farther north, you start to encounter pretty poor habitats food-wise. You're dealing with either the extensions of the Red Lake Bog, lots of lowland country, Cooch County bog, as well as the Canadian Shield bedrock. Think traditionally the Boundary Waters and the far northern parts of the Superior National Forest, as well as Lake and Cook County, the north ends of there. The soils are really thin. There's very little oak, and in general, the foods are in worse condition. And so on average, bears reproduce between 5 and 6 up there. As you move farther up into the boreal forests of Canada, there are some bears up near like Algonquin Park and some of the boreal forest where I've heard reports of bears not reproducing till 8. The longest we've ever had a bear wait to have her first litter was 10 in the state of Minnesota, and she was located in swampy country near Grand Rapids as well. So those swampy bears and bears that live in that low productive habitat take longer to reproduce. Back to the survival stuff. So those cause-specific mortality results don't tell the whole story because things are complicated with bears. Hunting is the largest source of mortality, and so let's dig into that a little further. Some of the earlier work that was done in the 90s by my predecessors, Karen Noyce and Dave Garcelis, they found some kind of foundational pieces about what happens here in Minnesota with the harvest. What they found is that young bears have the highest rates of harvest, 2 to 3 year olds, higher rates of harvest for males and females nearly across the board. Males are more likely to be killed than females in the harvest. That's just due to their naturally more bold nature and their willingness to approach baits more than females in general. And then food availability really affects males and females differently. In a good food year, you can almost always count on a harvest sex ratio that's male biased. The last 10 to 15 years, we're dealing with greater than 60% male bias in the harvest. But in a bad food year, there's a differential increase in the harvest of those reproductive females. And so what that means is when foods are bad, bears that wouldn't normally come to baits do so. And so that's typically reproductive age females. They're often more wary. Either they have cubs that they're bringing to the baits and they're less reticent to hit those during the daytime, during legal shooting hours, or just in general, they stick to natural foods. But when there are no natural foods around or very few natural foods around, they're more likely to hit those baits. And so that can be real problematic overall for the population if there's too many reproductive females taken. Similarly, by looking at a composite of what natural foods are overall on the landscape and the number of hunters, you can predict or explain about 80% of all variation in statewide harvest just with those two factors. Furthermore, harvest rates increase with the number of hunters for reproductive females, so that differential increase, if you really jack up the number of permits, can disproportionately affect those reproductive females. If you keep harvest rates low, it's more males that are going to be hit. And so for this phase of the study, we took those models based on the hypotheses from the early work, and we wanted to see, A, are they still relevant, and B, can we calculate hunting mortality rates specifically from all of our collared bears across those 4 study areas. We manage bears through hunting, and so we only use this hunting season data for this phase of the study. We looked at the plausible variables, as I mentioned before, and some of those interactions. And so this is a lot of text, but basically what we're looking at is hunting mortality influenced by the area where bears are, the age, the sex, the population size, total number of hunters, and food availability, as well as this fun one, which is asking hunters to not shoot collared bears. We put this piece in here because since 2000, we've been asking hunters not to shoot our collared bears because we want to learn what kills bears aside from hunting. And we wanted to see, is our messaging working? You know, does that have an effect on overall mortality rate of these bears, and has it skewed our results? Or can we treat these survival rates that we're getting from the harvest as, you know, as reasonable? And so the other things we looked at is interactive effects between food availability. Is it affecting males more than females? Oldest females, increasing number of hunters is greatest on those reproductive females, and some of those combinations identified by that earlier work. But the first thing we tested is, does that shooting of collared bears matter, or rather telling hunters to not shoot collared bears, does that actually matter? And the answer is no. And so hunters are still shooting bears despite our request. You know, it's not to the, we have a large enough sample size where it's not to the point where it's you know, a critical part of our study, like it would collapse our actual study, but there are bears killed every single year. And so what this means is probably we can use the survival rates we're getting even today when telling hunters not to shoot our collared bears, and they're probably similar enough to what things used to be back in the 80s and the 90s. So we dropped it from the model. We refit all of those models as shown in the previous slide. And what we found is the basic model is fine. What Karen and Dave did identified the key characteristics. There was no support for any sort of added complexity. And so what we found is that, in general, the things that they found are still true. So young bears are killed at higher rates than adults, pretty much across the board. Males are killed more than females, or at higher rates than females. And then as you increase food productivity, or rather as foods are more abundant on the landscape, the probability of mortality declines. Interestingly, the protective sanctuary part that we talked about from the earlier part of this research also carries through here. And so the probability of mortality in the Chippewa National Forest is almost twice what it is for the other 3 study areas, with some sort of either some sort of sanctuary or some sort of the big ear tags and that sort of deal in northwestern Minnesota. There's a similar pattern with number of hunters, but it goes the opposite direction. So as you increase hunters, logically, you're going to have more bears dying due to hunting. And so, again, those same patterns show up. Young bears are killed at higher rates. Males are killed at higher rates than females. And the protective sanctuaries have lower harvest mortality than those that do not. So the Chippewa National Forest, again, has double the probability of mortality for any given bears than the other 3 study areas. So to kind of sum up this part of the talk here, there's almost no natural mortality occurring on the landscape. Hunting is the largest mortality source. There are no areas where bears are free from hunting pressure, but bears in the places where hunting is not allowed have 50% lower percentage of mortality due to hunting. Weirdly, in northwestern Minnesota, that's that place where we figured would have at least some higher rates of hunting mortality than we expected, or than we found, I should say, due to those large chunks of public land. But in general, there's a lot of agriculture up there and private land, and so land access is an issue for hunters. In addition, corn and sunflowers are pretty tasty come around fall, and it's really hard to hunt a cornfield, and so that's likely serving as a de facto sanctuary as well. Once they leave the sanctuaries, then they're vulnerable to harvest, and that's where that harvest mortality comes from. But after you account for hunting, the hypotheses that we had for Camp Ripley voyagers in northwestern Minnesota were supported. Again, car mortalities are the largest source for Camp Ripley, natural mortality for voyagers, and then northwestern Minnesota, it's split between shot as a nuisance and car mortalities as well. They're not all that different from the statewide harvest data or any of the earlier work. As I mentioned, male mortality is almost always higher than females. Within sexes, the young bears have the highest mortality rates, and then foods are really important. And so I'll get to that in next here. So, if we want to have more bears on the landscape and we want to keep them, reduce the overall mortality rate to increase the bear population, we can do that by putting more plants on the landscape, but no one can control the weather. The old DNR weather machine that the climatology office has, that's been in the shop for years. I'm joking, there is no such thing. And bear foods are really only available for those 3.5 months in the summer. They need that time to pack on fat for reproduction, hibernation, and really the bulk of the weight that goes on bears happens in about mid-August until probably the end of September. Because of how we hunt in Minnesota, which is often with bait, those bad food years, as I mentioned, have a particularly harmful effect on the reproductive females, but food production is really out of our control. That said, we can understand how this works and plan for it just by reducing quotas or increasing quotas. So here's an example. Holding everything else average, average number of hunters in an average food year here, harvest probability of those reproductive females is 17%. So it's not super high. It's lower than that maximum sustained yield estimate. If you drop that and have a bad food year, that harvest probability increases up to about 24%. It's an almost 41% increase over an average year. And then if you look at the line here and figure out what that mortality rate would be in an average food year, those reproductive females are being killed at rates that would be similar to younger males, older males in an average food year. So there's where that disproportional change happens. In a good food year, harvest probability drops to about 12%, and it's about a third decrease over an average year in general. So good food years means females survive, which means you have more cubs being produced, and the population increases. So how does this apply to that old 20% guideline? Generally, we just use overall permit or population trends to set the permits up, down, or stable. If we want the population to increase, you can just cut permits back. If it's declining, we cut permits back. If it's stable, we leave things stable. If it's increasing, we can increase the permits a bit. But we really don't know what the effect of increasing or decreasing those permits on a per hunter basis is in context with food. And so if the idea here is to hedge against food failures, which probably are going to be more likely in a climate change scenario, we can use this discussion to make those decisions. And so here's that example again. This is that 20% mortality rate. So if we know we're going to have more bad fall food years, we can cut the permits down. If we know we're probably on it, or if we plan for the average, that's where we can set the quota. If let's say there's some magic wand waved and we have really good food years moving forward, well, that population can sustain more hunters. And so we can take that information into account when we set these quotas. Kind of to sum this up, we have a good handle on hunting mortality, and we can manage for it. It's kind of a staggering statistic to, tell people that, like, bears in the Chippewa National Forest, of all things that they die for, 80% of it's going to be from hunting. That's usually a staggering statistic, but the flip side of that is, from a management agency, we can actually control that mortality. Like, we can just cut permits if things are too high. 80%. I should clarify that that's not saying that 80% of bears die per year due to hunting. What it means is that of all things that bears die from, 80% of that mortality is made up of hunting. So that's an important thing to clarify here. And so the information we've learned from this, knowing that all bears are exposed to some hunting pressure, irrespective of where they live, is an important piece to know. And then regulated hunting as it exists now is a helpful tool for us. It's really what we can, we have good influence over the overall population. There's some lingering questions I still need to tap into this with the research. Reproductive status likely has a role in this, and there's a fair amount of unexplained variation in the models themselves. They don't explain a ton of variation in the overall system. It's a very noisy system. You think about all the things that might influence a bear from dying due to a hunter, individual choices, hunter behavior, the weather. Like, if it's too hot, sometimes bears will wait to go to baits until it's cool, that sort of thing. There's a lot of information out there I still want to try to tackle with this. But we can use some of this information to answer some of the questions we get from the public. So one common question we always get from the public is, how old does a bear live? In a hunted population, that's not necessarily a super relevant question, and it's kind of a hard one to answer. However, I could give you ranges. And so the average age of bears in the annual harvest over the last 40 years, at least for the last 20, for females has been 3. It's the median age. So what that means is half of the bears are age 1 to 3, and then the other half are 3 and above for females. And similarly for males, that median age is 2. This isn't super helpful because it's just a median average, and there's a pretty wide range. On the top end, we have bear 56, She was known as the Shy Bear. There's a nice article written up about her in the Conservation Volunteer that my predecessor wrote. So this bear lived near Grand Rapids. She was caught at age 7 and she died at 39 and a half. She's the oldest known wild bear ever recorded anywhere in the world. And she is the only bear that we've ever had on our study that's died to old age. She had stopped having cubs around 26, but she was never shot. She died midsummer. She was blind and deaf. The locals would keep an eye out for her, but you could honk a horn and she wouldn't really react all that much along the side of the road. In general, if you can make it to 15, you're doing really good as a bear in Minnesota. There are some places where bears live longer, but essentially, if you can avoid baits as a bear, you're going to be in good shape to survive longer. So the average person can't really do much to influence the hunting quotas. However, here's what you can do for bears if you're interested. You know, there's really no other bear food in the state of Minnesota that can substitute for acorns. And the choices you make about your land today can have long-reaching effects felt by your grandkids. The single most impactful thing that you can do is to leave those mature mass-bearing oaks on the landscape. You know, a single mature tree can produce hundreds of pounds of acorns for half a century or more. If you're doing a logging operation and you've got a lot of mature oaks on your property, shooting for 50% on average, you know, give or take 40 to 60%, is a good place to be. If logging is to occur, leave those seed trees in. And once you harvest, it's not a one and done. You got to come back in there periodically to thin some of that competition. Maple outcompetes oak. Aspen sometimes outcompetes oak, but you know, sometimes you get in those site issues, site-specific issues. But it's not a one and done, and so it's hard to manage for oak. It's tough to get oak to regenerate. And similarly, this is kind of an indication of that. This is the statewide FIA data as of 2019. That's the U.S. Forest Service Northern Research Station, well, U.S. Forest Service Forest Inventory Analysis data. And as you can see, those red bars represent the acres of oak forest types that are on the landscape, and private landowners are the primary holders of all of those forest acres. You know, if you add up the state, the county, and municipal, as well as the federal lands, we just don't hold much oak relative to private. And so, you know, private landowners are the ones that can help sway the tide or make changes, I should say, in the overall statewide oak forest. Something to call attention to is if you look at the age of our oak stands in general, they're kind of upper middle age. There are a lot of oaks in good mass producing conditions right now, but that won't be the case in another 15 to 20 years as those oaks age through the system. The circled box, or the box, shows where we have almost no oak regeneration in the 20 to 30 and the 30 to 40 acre stands. And so that is going to impact us moving forward, especially as climate change is supposed to favor oaks. But if we don't have oaks growing up, they can't take advantage of that change. Other things you can think about: Soil and Water Conservation District native plant sales. Here's an example of one from the South St. Louis County District. Get in contact with your local SWCD. Oftentimes they offer native plant sales. Any of the berry producing species in the state are good for bears. Dogwoods, cherries, service berries, plums, elderberries, raspberries, blueberries, blackberries, anything that you would think is tasty pretty much. Don't eat dogwood berries, obviously, but most of the edible berries that are good for people, bears also enjoy. Also on your lands, if you have an acreage, you can meet with a private lands forester and think about leaving some wildlife openings to simulate tree fall. Prescribed fire is an option in some land holdings. Controlling invasives, getting that buckthorn taken care of, and letting native fruit-bearing shrubs thrive instead is a good idea. Getting sunlight to the forest floor and thinking about a mixed diversity of forest types. You know, monoculture of 20 to 30-year-old aspen is probably not great. If you can let things get older and let some other species come up through, that's great. Mixed forest stands help provide that stability that the bears need in their habitat types. But to summarize, for what folks can do, oaks are most important, but fruit-bearing shrubs matter too. The best time to manage for oak was a half century ago, but the second best time is now. With that, I want to thank my predecessors who have helped out on the Bear Project. Dave Garschelis, Karen Noyce, Pam Coy, Spencer Rettler, Brian Dirks, Nancy Dietz, tons of DNR volunteers, and the bear hunters for giving us the information on all the teeth and the ages of our bears, as well as reporting when those collar bears were harvested as well. So with that, I will stop sharing and I'll be happy to take some questions. I'll turn my camera on, but pass it back to Benji and Craig to moderate.
Very nicely done, Andy. We do have quite a few questions that have come in during the presentation. And Maddie asked, you might address this later in the presentation, but how long do bears usually live if it takes several years to reach sexual maturity? And I think you covered that pretty well in your talk.
Yeah, 10 to 15 is doing pretty good. It really is variable on each individual bear, but 10 or 15 is a good ballpark. If you make it past 15, 16, you're doing really well.
Okay. Jessica wants to know how many bear permits are issued and what percentage of permit holders harvest a bear?
That's a good question. We have a couple areas in the state that are operated differently. We offer a quota area for what's primary bear range for the most part. And so this year we're giving out 4,000 tags for all of the quota area. And of those, the last probably 10 years, it's about 50% success rate. The trade-off is folks are waiting a long time to get those tags. I think the lowest wait times for most of the zones are 2 to 3 years, but there are a few high demand zones where you're going to be waiting 5 or 6 years before you get your opportunity to hunt. There are places in the state where you can just buy over the counter. Those are called the no quota areas. And those you can hunt every single year, but harvest success is low. It's, well, lower, I should say. It's between 20 to about 35%, and about half of the hunters in the state choose to hunt in the no quota. So we have about 8,500 or so bear hunters statewide every year.
Okay, very good. Mary wants to know, do other states that allow hunting also allow hunting over bait? If there are other states with hunting but no bait, do we know anything about their populations?
Yes. So it's complex and it varies by state. And so some states allow just baiting, like us. You can obviously still hunt without bait if you choose to, but about 92% of all of our hunters use bait. In some states, you can use dogs. Wisconsin and Michigan both have a hound season, and a lot of states in the southeast have a hound season as well. And then there are a few states where you can't use either of those techniques, Pennsylvania being the primary one there. And so the choice to use bait here in Minnesota was done really early, right when they were elevated to being a game species from a varmint. You know, coming into the 60s, they were considered a varmint. There's basically open season on bears 365, 24/7. And so when they were elevated to a game species in the 70s, that dropped the overall availability for people to shoot these things down to about 6 weeks. And then the choice was made to allow bait to allow for an ethical, clean shot and reduce wounding loss and that sort of thing. I don't know what the mortality rates are for bears in other states in general, but I can speak at least to Pennsylvania. So they have about 2,000 or 3,000 more bears on average than we do. They're right around 17,000, I believe. And they don't allow hunting over bait or with dogs. They allow anybody to buy a tag over the counter. They have 100,000 or so bear hunters, and they kill about 3,000 to 3,500 3,000 to 3,500 per year. So it's about a 3.5% success rate.
Very good. Let's see here. Jesse wants to know when during the year is it determined how many bear permits will be issued, and when are they issued?
Sure. So it's right now is when the lottery is open. It just opened yesterday, and I think it closes 15th of May. You can go on our website to double check. Benji put a link to that bear hunting page with all the dates in the chat there, and the number of quotas are set in the early spring, late winter. So hunters have to send in a tooth from the bears they harvest by the 1st of November. We age all of our teeth in-house with just one staff person, and she does all the aging of bears and has since, I mean, we've done everything in-house since the 80s. And then those results get put into the models. The models are run, and then we have a season setting meeting, usually sometime in February or early March. The committee makes recommendations up to the division director and the commissioner's office, and then they sign off on that in order to get things out for the early April lottery start.
Very good. This is from Mike. With a growing bear population, is there a population level you are trying to reach or sustain?
So this is another tricky question. We don't have any hard and fast numbers because that gets really, it's more difficult than like trying to balance a marble on the end of a 10-foot 2x4. It's real tricky. Partially because it's hard to estimate bear populations overall, and it's hard to hit that actual target. We don't have any set harvest goals like are identified in some of our other DNR plans, and so in general we shoot for kind of a Goldilocks approach. You know, we know what too high is, we know what too low is, and somewhere in the middle that has enough resiliency in the population. If we have a couple back-to-back bad food years, we don't have to make drastic cuts to the quotas, is kind of how we manage things. And so it's done through adaptive management, and we adjust those things every year as needed. We generally manage things on an up, down, or stable kind of framework rather than setting any sort of hard numerical targets.
Okay. Mike had a follow-up question. How accurate is your aging data for bears? Is their aging mostly done by teeth submitted by hunters? And how do you age a radio tagged bear?
That's a good question. So for the hunter data, those are all aged in-house. We have a video up on our YouTube channel that shows kind of how we do that and how we use that data. But essentially you section these teeth, or rather you decalcify them, section them, and cut really thin slices and mount them on a microscope slide. They're then stained, and our lab specialist and biologist reads them and estimates the age. It's not perfect. It's difficult to get ages on teeth that have broken tips. So it's really important if you're a bear hunter to make sure you get the entire root. Otherwise, accuracy decreases. And then we use the same technique with a commercial lab for all of our radio collared bears. So anytime we capture a bear, we pull a tooth, we get the initial age, and then we can track that through. In addition, we have collared bears, and so we know when they're born because we collar yearlings, so bears that are a year old, and then we follow them through their life, at least for this phase of the reproductive study. And so we have actual known age bears as well. The tooth cementum aging stuff was all kind of figured out in the 70s with known age bears using that same sort of technique, like watching bears from cubs and then pulling teeth as they go. And it's pretty standard pretty standard, but one of the common questions I get is, well, it couldn't possibly be a 3-year-old bear because it was this weight or whatnot. And one of the things we found is in the last 20 years, especially out on the, not only statewide, but especially out on the edge of bear range, is that bears are heavier now than they were, you know, even 20 years ago by a substantial margin. So what we're talking about is like a 4-year-old bear now weighs what an 8-year-old bear would have weighed 20 years ago out on the edge of air range. And so they're reaching maturity much faster than they used to. And so if you kind of get an age for when you could hunt back in the 80s and the 90s, is like, all right, this is what a 3-year-old bear should weigh. Well, that's not accurate anymore because, not only is food in the forest more available, there's more oaks on the landscape now, there's more corn on the landscape now, but also baits have gotten better. There's a lot of people baiting with food that's super high quality and would replicate what the bear's diet would be naturally. There's a lot of people using mixed nuts, trail mix, that sort of thing. And while it does have chocolate, that's not so great for bears in general. Nuts really can allow them to pound on that or pack on the pounds quickly.
Okay. This questioner wants to know if building a wildlife road across would help bears. Are there any plans for crossings? How could I help promote building of crossings? And how could I help promote building crossings? I know we've done that for like deer, but I've never seen or heard of one for bear.
Yeah. In general, vehicle mortality isn't a huge part. Even if I would say on average we get about 6 to 10 reports of bears killed on the highway in any given year, and even if it's 10 times that rate at a statewide level, it's still a really small proportion of the overall bear population. If you're dealing with 13 to 17,000 bears, it's a real drop in the bucket, and so it's not something we're critically worried about at this time. There are places out west and in Canada where you're dealing with deep mountain valleys and huge interstates, and so there they do have overpasses. The Bow River Valley in Alberta is kind of the classic example of that. But there's really no plans for any sort of wildlife overpasses specifically for bears, but it can work in some cases. Out east, there's a couple major highways that they've done that, mostly underpasses. Out in the Alligator River Valley National Wildlife Refuge out in North Carolina.
Okay. Jesse wants to know, do you think bear populations will be hurt by climate change in Minnesota due to increased temperatures or helped more by increased oak range?
It depends. Getting a biologist thumb down to make a definitive prediction is always a hard thing. So I'll freely admit that I'm perpetuating that situation. It really depends. I don't think we're going to be growing a lot of oaks up in the boundary waters where there's thin soils, and so probably there's going to be a time lag there before bears would be able to capitalize on that up north. That said, in general, bears are probably going to be climate change winners, relative to some of our other species that can't handle those higher heats like moose. That said, if things get drier and drought is more common, then you have situations with more periodic food failure, which would not be super great for bears. But as long as we don't have any sort of widespread decline of oak across the state and things keep going the way they're going, bears should be fine.
So we've got about 6 minutes left and we have got a lot of questions, Andy. So we'll try to get through as many as we can. Tom wants to know, in the northeast part of the state that has few, if any, oaks, what are the primary food sources related to population?
Yeah, so where there isn't oak, they make do on what else is there. And so like on the North Shore, mountain ash is actually quite a popular food where it's present. Throughout the rest of the Northeast, dogwood is a really common fall food, as is hazel, beaked hazel primarily. And some of those late season other species that would be common, like in Orr, Greenie, that kind of country south of Kabetogama, they capitalize on wild plums when they're available. Similarly, they'll eat a whole bunch of high bush cranberries when those are available as well. They're not quite as palatable as some of those other species, but they will make up that deficit where where oaks are not present.
Okay. Lori wants to know, is it true that bear reproduction determines litter size? Or is there a female hereditary factor?
Um, Probably genetics plays some role. It drives a lot of things, but what we find is that the first litter is often smaller than the subsequent ones, and then after that, it's pretty regular. Females that regularly have 3 will have 3 pretty commonly. There will be some variation there, but 2 is more common for the first litter, and then 3 after that.
Okay. And I think you've covered this a little bit, but why is bait used for bear hunting and not other big game animals?
That's a complicated question. The decision for bear baiting was made just because of how dense our forests are. It would be tough to have a season in which you could have a lot of bear hunter success and use hunting as that tool to control the population, or rather manage the population. The decision was made back then to allow it for a nice ethical clean shot, because the bears are being held there longer. Bears don't have some of those communicable diseases that we're really worried about with some of the other species. But it depends on each individual state and what they allow and what the management priorities are. So for bears, it's a very short time period, and it's not anywhere near town, and that seems to work for us. If we weren't to allow bait, we could probably let 100,000 hunters go, but the success rates would be really low, and we'd lose that management tool.
Mm-hmm. This one here I'm struggling with a little bit. Will spotted wing dysphilia impact the berries to a point where it will be a problem for bears?
Okay, so this is an invasive fruit fly species that's shown up in the last 10 years or so, throughout the state. It's wreaking havoc on a lot of commercial blueberry and raspberry producers, among others. And we put out traps at a number of places in the Chippewa National Forest just to see if they were present. And when we reached out to MDA about it, they basically said the whole state has spotted wing Drosophila now, pretty much. And so
Okay.
it's, I don't think it's going to be to the point that it's going to, really mess with fruit in general for bears on the landscape, because they can switch around a number of species. But it always seems like it's death by 1,000 cuts with invasives. As things show up, then it makes things easier for others to show up as well. Earthworms are another ones that are impacting some of these, some of the fruit production as well. It destroys the mycorrhizal communities of the plants, and they just don't seem to produce quite as well, even after you account for canopy cover and some of those other things.
Do bears have an effect on deer populations?
They can in some places. In general, a nice way to phrase this is that bears are lazy. And so the fawns in general are vulnerable to bears just usually during that first week or 2 of life. After that, the fawns are fast enough to get away, and it's just not worth it for the bears to even mess with. Similarly, berries show up around that same time, and it's just easier to eat berries. Out east, there are places where a good proportion of the mortality that fawns receive is due to bear predation, but in general, we don't find deer fawns in a lot of scats, based on some of our diet work. In some spots and parts of the state where there's very low deer populations, yes, bears could play a role in keeping those suppressed, but in general, it's not a population level effect that we've noticed.
Same for moose calves?
Same for moose calves. There are small places where they are certainly playing a role. But in general, based on all the other things that are out there, it's not the leading factor that's causing those declines by themselves.
We are at 1 o'clock, Andy. We have a few questions left, but we're not going to be able to get to them. I'd like to remind everybody to tune in next week for climate and landscape changes and their effects on cold water fisheries. That'll be episode 159. And I thank you so much for being here today, Andy. This was awesome. We can take a look at the questions and um, let you see what was left, and maybe we can figure out how to get there. So
Sounds
thank you,
good.
everyone.
Yeah, thanks everyone. Andy, great job. I did want to point out, we did have somebody ask about trees up in Itasca County, and Caitlin put in the Q&A that SWCDs are taking orders now for trees. So if you are a landowner across the state, reach out to your local soil and water conservation district and get those orders in and go from there. So thanks everyone.
Thanks, everyone.
Thank you.